Quick geometry review. Arc length. If an object travels around any part of the circle, then there is a distance that the object has traveled. In its circular motion, this distance has a special name. It's called the arc length. You can use this symbol D or capital L for distance, length, arc length. However, sometimes we use the letter S for arc length. Maybe that rings a bell for the equation that you memorized in your geometry class. The arc length of the car making its turn is shown in green. Note that it is 1/4 of the circumference of the best fit circle, because the turn was a 90-degree turn, and 90 degrees is 1/4 of a circle. If an object travels around any part of a circular path, then there is an angle between its starting point, the center of the circle, and the ending point. This angle is called the arc angle with the symbol theta. So just like we've always used theta for our angles, we're still using theta to talk about the angle that it has moved through. In the example below, the arc angle is the angle of 1/4 of a circle, shown with red lines. There we go. We can either express arc angles in degrees, like 90 degrees, or we can express them in radians. So pi over 2 radians. There are 2 ways to split a circle into angle pieces, degrees and radians. There are 360 degrees in a circle. The circle below on the left is shown in 30-degree pieces. There are 2 pi radians, about 6.283 radians in one circle. The circle to the right is shown in 1 radian pieces, along with the last piece, 0.283 radians. In physics, it's easiest to talk about angles of a triangle using degrees, but with circles, we use arc lengths and arc angles using radians. Why are radians easier? So let's say you're asked to find the arc length of the arc shown below, where the radius of the arc is r and the angle of the arc is theta, and the angle is given in degrees. To do this, you have to set up a ratio, like arc length divided by total circumference equals arc angle divided by the total angle. This would look like this: s over 2 pi r equals theta over 360. Solving for s and reducing 2 and 360 would give s equals pi times r times theta divided by 180. Now, instead, we're asked to find the arc length, but theta is given in radians. Let's set up the same ratio and see what happens. Remember, there are 2 pi radians in a circle. Arc length divided by total circumference equals arc angle divided by total angle. So it's going to look like this: s divided by 2 pi r equals theta divided by 2 pi. Note that the 2 pi will cancel out. So this becomes s, the arc length, divided by the radius equals theta, the arc angle. Solving for the arc length, we get s equals r times theta. There it is. There's that arc length formula. This is a very convenient equation for arc length. It's better than s equals pi times r times theta divided by 180 when working in degrees. Please remember that length equals radius times radians. That doesn't really answer what a radian is, though, right? Let's talk about what a radian actually is. So let's say I have this round circle right here, and I have this piece of tape, which is the length of the radius of the circle. If I take the length of this radius and I apply it around the circle, that length right there is 1 radian. Guess how many times I can take the same piece of tape and put it around here? 2 pi. So there are 2 pi radians in one circle. So if I take the length of the radius and just apply it to become an arc length, there's 2 pi of those. Sorry if you already knew that, but my 10th grade geometry teacher did not explain that very well to me. So, when discussing how fast an object moves around a circle, we can communicate how fast by using one of 2 quantities. Linear speed, how many meters of arc length the object travels around the circle every second, using the symbol v. Meters per second, right? This is the same thing as the speed we've talked about this entire year, so we're just going to call it linear speed to make it sound different from angular speed, also called angular frequency. how many radians of an arc angle the object travels around the circle every second. The symbol, this is where we start learning some Greek. The symbol is the lowercase omega. It's not W, it's rounded, so that's how we know it's omega. The units are radians per second, rads per second. Linear speed is length over time, distance over time, right? So to calculate linear speed, we can just use the length around a full circle, or the circumference, and the time around a full circle, the time it takes to make one full circle, the period. So the circumference is 2 pi r divided by the period, and that would be the speed. Because period and frequency are reciprocals, we can also say v equals 2 pi r times f. Angular speed is angle over time. So to calculate angular speed, we're going to use the angle of a full circle. Remember, there are 2 pi radians in one full circle, and the time around one full circle is called the period. So the angular speed is 2 pi over period. Because period and frequency are reciprocals, we can also say that omega equals 2 pi times f. This is on your equation sheet. So know it. Don't spend so much time memorizing it. It's good to know where this stuff comes from. It's really good to know that velocity is a distance over time. And if you go completely around a circle, then you have gone 2 pi r. You've gone the circumference around the circle. So if we think about space, the Earth goes around the sun in 1 year. So the distance that it's traveled is 2 pi r. That r is going to be the distance from the Earth to the sun. The time it takes is going to be 365 days converted to seconds. An enormous number.